Another function, another rule, natural logarithms. We studied this in grade 11. So the domain for domain of rational natural logarithms, you take the stuff written with ln and set it as greater than 0. Remember the ln function? It was like this. Y-axis was the asymptote. It wasn't touching and crossing the y-axis. So we are writing greater than, not equal to. It's never equal to 0. And its range is, since the graph is extending up and down in both directions, it's all real numbers. It's very simple. So ministry question, ln x minus 2, find the domain. So set the stuff beside radical as greater than 0 and move 2 to the other side. X is greater than 2. Write this as interval notation. 2 to positive infinity, option A. Let's move on. Exercise question. Find domain and range. For the range, you can directly say it's all real numbers. For the domain, you set this stuff 1 minus t to greater than 0. Bring 1 to the other side. Negative t is greater than minus 1. Get rid of this minus by dividing or multiplying both sides by negative 1. When you do this, these both of them will turn positive and the direction of the inequality symbol changes. So t is less than 1. Write this as an interval notation. Less than 1, numbers on the left, smaller than 1. So numbers are from negative infinity to 1, exclusive. Alright, so 2023 first attempt ministry question. The domain of which function is from negative infinity to 4? So let's look at ln first. 4 minus x must be set as greater than 0. Bring 4 or x to the other side. Negative x is greater than negative 4. Multiply or divide both sides by a negative number. So the direction of inequality symbol will change. From x is less than 4 means from negative infinity to 4. So that's the correct answer. When you look at the others, for absolute value functions, its domain is all real numbers. For this one, 4 minus x is greater than or equal to 0. But here there is no equality. The bracket is open. B is not possible. And for A, 4 plus x must be greater than 0. In this case, 4 is greater than negative 4. Our number is 4, not negative 4, so that's not possible either. Option C is true. That's a nice question. You need to know domain of 4 different functions. Let's move on. Another rule, another function, trigonometric functions this time. So before we study domain and range of trigonometric functions, let's remember some important things about domain trigonometric functions. Their x and y intercepts. So what are the x-intercepts of sine function? You equalize it to 0. When sine is equal to 0, x is, the angle is, the stuff written with sine is k pi. K is an integer. For cosine function, the x-intercepts of cosines. What is the x? When you equalize it to 0, the x, the angle. This can be any angle. It doesn't have to be x. It can be x plus something, x minus something, x multiplied by something. So by x, I mean the angle. So x will be pi over 2 plus k pi. K is an integer. And we also need to know that tangent is sine over cosine. So these are the stuff that we studied before and which is very essential to know. And let's talk about domain and range for trigonometric functions. So when you have trigonometric functions written as a times sine or cosine bx, then the domain is all real numbers. No matter what your coefficient is, no matter what your angle is, it's always all real numbers, the domain. The range the range is determined by the coefficient. Look at the coefficient of sine or cosine. So it's always from negative of this coefficient to positive. Let's take a look at questions. A ministry question. This question is asked twice. The range. It's asking about the range. So we need to focus on the coefficient. What is the coefficient? 2. According to this rule, from negative of this coefficient to positive of coefficient, inclusive will be the range. So it's option C. Find domain and range. So for the range, we focus on the uh, coefficient. Coefficient is negative 3. So from negative 2, positive 3. For the domain, it's always all real numbers. Because remember the graph of sine or cosine, it's wavy shape, right? It keeps going infinitely from both directions, in both directions. So it's always all real numbers. So domain and range of tangent. Remember tangent function. It is something like that. And it keeps going infinitely. But there are asymptotes, if you remember. There are some excluded values. So what are these excluded values? We're going to write the domain as all real numbers minus those excluded values. So what are those excluded values? When you rewrite tangent, it is sine x over cosine x, and we have a denominator. It becomes a rational expression, and we have a denominator. For rationals, remember, domain is all real numbers except what makes denominator 0. So what makes denominator 0? R minus zeros of denominator. So what is the denominator? Cosine x. So we just know that when cosine x is 0, then x is pi over 2 plus k pi. We will write this. We need cosine. We need the numbers that make cosine 0. So when cosine is 0, so what are those values that make cosine 0? So x is pi over 2 plus k pi. So then we will exclude those values from the domain. So r minus pi over 2 plus k pi. K is an integer. Will be the domain, and the range, it extends up and down infinitely. It's always all real numbers. Okay. It is similar for 1 over 10. It's in the book. Check it out. Question 1 over sine over cosine. Since there is 1 over sine over cosine, you flip it, becomes cosine over sine. For range, you can directly say all real numbers. This function only changed the graph like this. It's still same. We have asymptotes and extends up and down infinitely. So range is all real numbers. Domain is r minus zeros of denominator. So what is the denominator? Sine x. So what makes sine x 0? What are the numbers that make sine x 0? Remember the rule. When sine x is 0, x is k pi. So we will write x is equal to k pi. K is an integer. So range domain is all real numbers except k pi when k is an integer. So this is the way to find domain and range of tangents or 1 over tangent functions. Sine and cosine are simple. Tan is also simple when you know the rule. Okay, another important thing about trigonometric functions. There is only one ministry question about this situation. They only ask this once, and there is one question in the book about this in check it out part. If your function is written in this form, and in rational expression form, number over number times sine or cosine of something. So sine or cosine is in denominator. In numerator, you have constants. Then the domain is still the same, all real numbers except what makes denominator 0. But the range is different. The range is from negative infinity to a negative of the coefficient. The coefficient is a over b. Union, positive of the coefficient to infinity. You take the coefficient, the top over the coefficient of the bottom will be the coefficient, right? A over b is the coefficient. It's negative version, negative infinity to negative version, union, positive version to positive infinity. For example, 2022 first attempt ministry question. It's asking about only the range. So apply the rule. What is the coefficient first? Negative 1 over 1. You have 1 in denominator, 1 in numerator, but negative in front. Coefficient is negative 1. So according to the rule, look at the rule. Negative infinity to negative of this coefficient, negative 1. It doesn't matter if the coefficient is negative or positive. You write the negative 1 first. Exclusive union, the positive 1 to infinity. So it's option B. If you don't know the rule, it's not possible to solve it. You can just pick randomly, but if you know the rule, you can just solve it by eyes. Let's solve one question. The range. Let's answer the range first. Look at the coefficient, 5 over 4. So from negative infinity to negative 5 over 4, exclusive, union, 5 over 4, the positive 5 over 4 to positive infinity is the range. The domain is tricky. It's all real numbers except zeros of denominator. So what are the zeros of denominator? In denominator you have 4 cosine pi x. So what makes 4 cosine pi x equals 0? Divide both sides by 4. So cosine pi x is still 0. 0 over 4 is 0. And apply the rule. What is the angle? Angle is not just x, it is pi x. So when cosine is 0, then remember the rule. When cosine is 0, then x is pi over 2 plus k pi. By x, we mean the angle. Our angle, pi x, is pi over 2 plus k pi when k is an integer. So write domain as r minus this. Sorry, I didn't get x alone. Let's get x alone first. I need x alone, so divide everything by pi. So now x is alone, 1 over 2 plus pi and pi will cancel k. So r minus 1 over 2 plus k, when k is an integer, will be the domain of this function. All right. Okay, another rule. Combination of functions. When there is addition, subtraction, or multiplication, then first of all we find the domain of each function separately and take the intersection part as the domain of this combination. So the combination of functions domain is the intersection domain. For example, a ministry question. Find the domain. So find domains separately. First, domain of x, the stuff on the radical must be greater than 0. X minus 1, stuff on the radical is greater than 0. So x is greater than 1. So what's the common part? Let's put them on the number line. For the first one, greater than 0, 0, open. So shade the right side, greater than 0. So this is the domain of the first function. The second function, 1, x is greater than 1. 1 is open. Shade the right side again. So take the common region only. So what is the common region? Between 0 and 1, I only had the green color. I only had the one color, one function. But after one, I have both green and orange together. So this is the common part, intersection part. So this will be our domain. So domain is from 1 to infinity, exclusive. All right, so the answer is D. Excuse me, I wrote this wrong. It's supposed to be greater than or equal to. So they are included. This is radical. So under radical, it's greater than or equal to 0. So option D is true. Next question, a similar one. Find domain separately. 2 minus x is greater than or equal to 0. Minus x is greater than or equal to minus 2 when you bring 2 to the other side. Divide both sides by negative. Change the direction of inequality symbol. X is less than or equal to 2. The other one, x is greater than 2, 0. Greater than or equal to 0. So I have subtraction. I may have addition. I may have multiplication. It doesn't matter. In every situation, we are going to do the same. Find domain separate and find intersection part. So 0 is here. 2 is here. Okay, let me use different colors. So for x is less than or equal to 2. So we shade the left side. Smaller than 2. We shade left side of 2. And for x is greater than or equal to 0. This is bigger than 0. So we shade right side of 0. And pick the common region. Which region is common? Here I have only orange, bigger than 2. Less than 0, I only have a green, but between them, we have both colors. So this is the common region. So our domain is from 0 to 2, inclusive. All right. Okay, we have more functions. This time, let's study composite functions. The domain of composite function f composed with g of x is the set of those values of x in the domain of g, for which g is the domain of x. This sentence is a very complicated sentence. In a nutshell, it says, when it's asking about domain of these composite functions, find the composite function first, find its domain, and it's not enough to find domain of this composite function. We need to check the inside function too. So check the inside function and check the results. So take the common region, take the intersection region. So that will give you the domain. Okay. So let's solve two questions and see what happens. So a ministry question, find domain of f of g of x. So put g into f first. Put g into f first. So let's write the composite function. F of g of x is, when you put g into f, it's negative square root of g inside 4 minus x squared. Now what kind of function do you see here? Number minus x squared. I see a semicircle. So I can find my r squared. R squared is 4. So r is 2. So the domain will be from negative 2 to positive 2, inclusive. It's pretty simple if you know what kind of function you have. Okay, when you switch the order, what happens? Instead of finding f of g of x, let's find g of f of x and see what happens. This time you put f into g. F into g. So let's write the composition. G of f of x is equal to 4 minus negative square root of x squared. Let's simplify this. 4 minus square root of x squared is just x, right? 2 and the radical will go. When you square minus, it becomes plus 4 minus x. So we are going to find two domain. So domain of result. What is the result? 4 minus x. It's a polynomial function. So domain of polynomial functions are all real numbers. What about domain of inside function? What is the inside function? F is the inside function. It's a radical function. So for radicals, take the stuff under radical and set it as greater than or equal to 0. So what is the common part between them? Take the common part, intersection part. Bigger than 0 and all real numbers. So it is the smaller one. X bigger than 0 is the domain of the composite functions. 0 to infinity. Okay, you can make a number line, put this on the number line. 0 to infinity, shade the right side. And for the result, all real numbers are possible. And take the common part. I have green here. I have black and green together here. So this is the common part. So 0 to infinity will be domain of the composite function. So be careful for such questions. If it were a multiple choice, I am sure all real numbers would be in options 2. But our answer is not all real numbers, 0 to infinity. So we always need to check the inside function when there is composition. All right. Okay, last function finally, piecewise functions. Domain and range of piecewise functions. Study guide 25C. So for domain, I can make a number line. And we have two pieces, two different regions. X is less than 0. 0 is here. Let's shade left side. And x is greater than or equal to 0. This time we fill the point, shade the right side. So for domain and range of the piecewise functions, we don't take the common, we take the union. So let's unite them. When you unite them, take all. So all real numbers will be the domain. So we shaded everything. So left side of 0, right side of 0, every number is shaded. So all real numbers is the domain. So this is different than composite or combination of functions. We take the union. We don't take the intersection part for domain and range. For the range, this is not that simple. We need to make a table. We studied how to make a table, how to find range of these kinds in grade 11. So let's do the same. I'm gonna make two different tables. One for the first one, x is less than 0, so function is x squared. The other one for the second one, x is greater than or equal to 0, when your function is 2 minus x. So give some values. X is less than 0. Start from 0. It's the boundary point, but this is excluded because it's less than. When x is 0, what's your y? It is 0. Pick a number less than 0, like negative 1. Negative 1 squared, 1. Pick another number less than negative 1, like negative 2. Negative 2 squared is 4, and so on. From starting 0, your y values are heading to positive infinity. These are the x values. Those are the y values, right? Y is equal to x squared. So these are the y values for the first part. For the second part, pick a number. First, use the boundary line. Boundary number 0. 0 is included. 2 minus 0 is 2. And give another number bigger than 0, like 1. 2 minus 1 is 1. Give another number bigger than 1, like 2. 2 minus 2, 0, and so on. From starting 2, our numbers are heading to negative infinity. It keeps getting smaller. 2, 1, 0, negative 1, negative 2, and it goes to negative infinity. So we unite those two y values. Unite them. So let's make a number line first, as we did in domain, and see what numbers are possible. So for the first part, 0 to infinity, 0 is here excluded to infinity, shade the right side. For the other part, 2 to negative infinity, 2 is here, bigger than 0, included, and we shade the left side, it's going to negative infinity. So this point also will be closed. So since we take the union, we take every number that's shaded. So is there any number is not shaded? There is no not shaded number. Every number is shaded. Left side of 0, between 0 and 2, right side of 0, everything is possible. So its range is also all real numbers. Domain is all real numbers. Range is also all real numbers. All right. One last question, ministry question. It's asking about the range. So we're going to make a table. If you want, you can sketch the graph, but it's not necessary. Making table is enough. I need two tables. X is less than 1. So our y is 1 minus x. When x is greater than or equal to 1, our y is square root 1 minus, no, x minus 1. Okay, pick numbers from less than 1, including 1, because it's a boundary number. I need to use it, but I need to know that's excluded. So when you give 1 to x, 1 minus 1 makes 0. Pick a number less than 1 like 0. 1 minus 0 is 1. Pick another number less than 1 like negative 1. 1 minus negative 1, 2, and so on. So as you give numbers less than 1, the y values are increasing. 0, 1, 2, 3, and so on, goes to positive infinity. Look at this part. Start with 1. 1 is included. When x is 1, 1 minus 1 is 0. Give a number greater than 1 like 2. 2 minus 1 is 1. Square root of 1 is 1. I want to give a number that gives me a number, a perfect square number, so that I can take it out. Or you can use the calculator. It's okay. Like 5, for example. When x is 5, it's greater than 1. When x is 5, 5 minus 1 is 4. Square root of 4 is 2. And so on. As you give numbers bigger than 1, y values are increasing. 0, 1, 2, and so on. Goes to positive infinity. So these are the y values for the second function. These are the y values for the first function. So you are going to combine them. So let's make a number line. Put them on the number line. For the first part, 0 excluded to positive infinity. Shade right side. For the second part, 0 to positive infinity. This time 0 is included. Shade the right side. So it seems I shaded only 0 and the right side of 0. So its range becomes 0 to infinity. 0 is included. 1 excluded, 1 included makes included. 0 to infinity. Option B will be the answer.